N-fulva is an ant species native to Brazil and an invasive species in other South American countries. When exposed to S. invicta venom, the N-fulva secretes formic acid out of its acidopore, rubs it onto the areas of exposure, and effectively detoxifies the venom. This behavior is the main factor in the N-fulva becoming a dominant invasive species and outcompeting the native fire ants. So the question I sought out to answer in this report is the effectiveness and technique of the detoxification behavior of the N-fulva in response to the venom of S. invicta similar across other Formicinae species? I concluded that multiple Formicinae ant species related to the N-fulva demonstrate similar effectiveness and technique in detoxifying the S. invicta venom. The detoxification behavior is when the Formicinae ant species secrete formic acid out of their acidopore and rub it onto the area of exposure to venom. The average detoxification behavior counts for each Formicinae species within the most active 2 minutes after exposure was calculated. Unpaired t-tests conducted compared the N-fulva average count to each species average count. Here we see the figure shows that the F. pallidifulva, the N. vividula, and B. patagonicus average detoxification behavior counts were not significantly different compared to the N-fulva count. Thus, we can conclude that they exhibit similar techniques in detoxifying the S. invicta venom. Figure 2 demonstrates the percent survival of Formicinae species exposed to S. invicta venom. The percent survival of the Formicinae species at 7 hours after exposure to S. invicta venom was calculated. Manual t-tests were conducted to compare N-fulva to each species. From this we can conclude that all Formicinae species compared to the N-fulva exhibit similar effectiveness of the detoxification behavior. All species survived exposure to the S. invicta venom at high rates. So why do these findings matter? As said earlier, the N-fulva ants are an invasive species across South America, displacing the native fire ants using their detoxification behavior. Invasive species outcompete native species for resources and disrupt many processes within the ecosystem. If other Formicinae ant species can exhibit similar effectiveness and technique in detoxifying S. invicta venom, then they may exhibit similar levels of invasiveness as the N-fulva. Thus, it is important for conservationists to determine if other Formicinae species can be as invasive as the N-fulva to prepare efforts to prevent harm to ecosystems of invasion. Data from the Excel sheets were utilized to calculate the percent survival of all 8 ant species after exposure to S. invicta venom. Table 1 at the top has been modified and represents a piece of the N-fulva solo data. It also includes a summary. Only a few rows are included. Table 2 on the bottom is a summary that represents the other Formicinae species data. From the Excel data within each species, the total amount of ants that survived exposure to S. invicta venom after 7 hours was divided by the total amount of ants exposed to the S. invicta venom. This value was multiplied by 100 to get the percentage value. Data from the Excel sheets were utilized to calculate the average detoxification behavior count, standard deviation, and standard error of all 8 ant species after exposure to S. invicta venom. Table 1 on top has been modified and represents a piece of the N-fulva solo data. Only a few rows are included. Table 2 is a summary that represents the other Formicinae species data. The species' most active 2-minute interval after exposure to S. invicta venom was examined and the average detoxification behavior count, standard deviation, and standard error were calculated all within Excel.